Good morning, good evening, good afternoon, in whichever time you are watching this. Myself Dipen Sharma, student of Sikkim Government College Namchi, bearing roll number 20NS0306, would like to present this video on the topic UV visible spectroscopy and cyclic voltmeter, and it consists of 25 marks, paper 7 sessional B, and I would like to thank Department of Physics Sikkim Government College Namchi and to our concerned teacher Dr. C.P. Khatiwada. So without wasting, let's get started. UV visible spectroscopy is a quantitative analysis used to measure how much a chemical substance absorbs light. It is a quantitative analysis. Quantitative means we are only interested in numbers, and it measures how much a chemical substance absorbs light. It is totally dependent upon absorption of light by a chemical substance, whether it is molecule or atom or any aqueous solution, whatever. Basically, it is done by measuring the intensity of light that passes through a sample. We are provided with two samples. One is of blank, or we can use it as a reference sample, and other one is of unknown, and we have to determine its concentration. It was all about introduction. Arnold Beckman in the year 1941 invented UV visible spectroscopy, and its purpose is to quantitative determination of analyte or given sample. Concentration of the sample is determined, and also it helps for structural representation. And the next is, it basically work on the principle of absorption. Light is absorbed during electronic transition from low energy orbital to higher energy orbital. Okay, and followed by the excitation of electrons. For many other spectroscopic technique, absorption phenomena is also used. For example, we can take IR, NMR, etc. The range of wavelength is for UV is from 200 to 400 nanometer, and for visible light is 400 to 800 nanometer in electromagnetic spectrum. Now instrumentation. A monochromator is used. A monochromator is an optical device that transmits a mechanically selectable narrow band of wavelength of light from a wide range of wavelength available in the input. It is basically a prism which allow white light to split into 7 different visible colors, and through a narrow slit it passes through the sample or the cuvette. We can see here a single wavelength of light is incident on prism or a monochromator, and it separates it into different wavelengths from range from 1 to 7, as there are 7 different colors in white light. Monochromator means mono means single, and chromator it relates with wavelength. Another is cuvette. Cuvette is used to store the sample, and there are two types. It is of two types. One is of known sample or blank sample, and other one is unknown. And it is either controlled or blank. When light passes through the cuvette, no change is seen in the intensity of light. Or in other words, there is no adsorption phenomena. The incident light is nearly equal or equal to the transmitted light in case of that of known sample. No electronic transition at all, and no electronic excitation at all, because there is no any sample, or we can take it as reference sample. The cuvette is basically made up of glass, quartz or plastics, and is used for analysis in spectrometer. Similarly, the next cuvette, we placed a sample which is unknown, and here we incident a light, and when it strikes the sample, some amount of light is absorbed and some amount is transmitted. When incident light of intensity I0 strikes the Remaining amount of light is used for adsorption in electronic excitation. Here we can see intensity of incident light is I naught and intensity of transmitted light is I. That means some amount of light is transmitted and some amount of light is absorbed by the excitation of electrons. And the length of the cuvette is L and concentration of the solution is C. In case of control or blank sample, intensity of incident light is similar to that of intensity of transmitted light, but that is not in the case of sample which is unknown. The intensity of incident light is used in two pathways. One is for transmission and one is for absorbed. One is absorbed by excitation of electron from lower energy state to higher energy state. We use detector for detection of that transmitted light. A silicon or photosensitive material is used. Silicon or photosensitive material. It is used as a detector. Especially we used PMT, that is photomultiplier tube. So here is the systematic diagram for UV visible spectroscopy. From the source, a single wavelength of light get passed through a slit entering into a monochromator, and then the monochromator separates the light in 7 different wavelengths. Monochromator is actually a prism, and through prism only a single wavelength of light through a slit enters into the separator. Separator separates the light and in two pathways. It follows two pathways. In one pathway there is a blank sample and the intensity of light incident is equal to the intensity of light transmitted. And in the second step we use a sample cuvette which is unknown, and the intensity of light here is not equal to the transmitted intensity, and some amount of light is used for excitation of electron from lower energy state to this higher energy state, and it travels and it gets to the detector, and the detector will detect how much it is transmitted or how much it is absorbed. So if we plot transmittance versus concentration graph, as concentration increases transmission decreases, which means the more the concentration the lesser is the light transmitted and higher will be the absorbance, because absorbance is inversely proportional to transmittance. Transmittance is intensity of light transmitted by intensity of light incident. And similarly, if we plot concentration versus adsorption graph, we will get a straight curve. As adsorption increases, concentration will also increases, which means at concentration 0, adsorption is 0, and we can quantitatively determine that of unknown solution or unknown cuvette or unknown sample, and absorbance is equal to I naught, which is intensity of incident light divided by intensity of light transmitted. Beer-Lambert's law. Lambert's law states that the absorbance of a material sample is directly proportional to its thickness, which means absorbance is directly proportional to its thickness. Here thickness is the thickness of the cuvette, and Beer's law states that the absorbance of the material is directly proportional to its concentration, which we have just seen in the graph concentration versus absorbance graph, which means absorbance is directly proportional to concentration and is directly proportional to the length or the path length, which is length of the cuvette, which is equal to epsilon naught times concentration into path length. Absorbance is equal to epsilon times concentration times its path length. And for convenience we use L as 1 centimeter. Now application. It is applicable in two ways. One is quantitative and another is qualitative. In qualitative way, we can identify the molecule in any biological mixture or any pure state. Example in proteins, nucleic acid, etc. And in quantitative analysis, with the help of standard curve, which we have seen in concentration versus adsorption curve. The quantity of unknown molecule or solution or sample can be determined quantitatively. So thank you for watching this, and I hope it was useful.